Hello, everyone. Thank you for tuning in to the LOA segment, Marvin Test Solutions, making test easy for the armament maintainer. If at any moment you have any questions, we welcome you to type them in the chat. Just include your full name, organization, phone number, or an email, or you can also reach us with the following contact information that will appear on the screen shortly. My name is Jessica De La Torre, and up next we will be hearing from Marvin Test Solutions' CEO, retired Major General Steve Sargent. After retiring from the U.S. Air Force in 2012, General Sargent was appointed Chief Executive Officer of Marvin Test Solutions and Vice President for Strategic Development for the Marvin Group. With over 30 years of senior executive experience in all aspects of military and commercial aerospace operations and operational testing, and organizations ranging in size from 200 to 160,000 personnel, Steve is leading Marvin Test Solutions' growth as a global leader, serving military, aerospace, and manufacturing organizations. Without further ado, I'll pass the microphone to Steve Sargent.
Thank you for that warm introduction, Jessica. It's great to be back at LOA, and it's an honor to be asked to speak to this important gathering of dedicated maintenance and logistics officers who've committed their lives to move and sustain the force. Good morning, ladies and gentlemen. Thank you for virtually tuning in. Over the weekend, I had a chance to spend some time with my family while preparing my presentation. During that time, I discovered how everyone wanted to assist me. For instance, when my wife started reading over my shoulder, her advice was, whatever you do, don't try to be too charming, too witty, or too clever. My son's advice was concise and to the point. Just emulate the latest fashion trends. Be long enough to cover the subject, but short enough to be interesting. Then be gone. If this is your first time attending LOA, I hope that you will take advantage of the time you spend here by visiting the virtual exhibit halls, expanding your network, attending the technical sessions and tutorials, and speaking with industry leaders. Whether you're tasked with maintaining legacy automated test equipment, designing a new test solution, or looking for someone to do that for you, chances are you'll find what you need here at LOA. If you've been here before, I'll bet you have a long list of exhibitors and people you want to catch up with. Since you tuned in, you're probably already aware of the importance of test in maintaining mission-critical systems. I'm also sure as maintenance and logistics officer, you're keenly aware of how difficult it is to hold aircraft down to accomplish test, constantly juggling operational and maintenance requirements. Mission readiness is the name of the game, but this means different things to different groups within a wing. Readiness within a maintenance organization requires comprehensive testing of mission-enabling systems throughout all three maintenance levels once deployed. With lives on the line and mission objectives to be accomplished on the first pass over target, the American public depends on us all to ensure the health and readiness of these systems, whether on the flight line, in the back shop, or the depot. Over the past several years since retiring from active duty at the end of 2011, I've had the opportunity to spend a considerable amount of time with maintenance across the globe. Maintainers, especially armament maintainers, discussing the manned, unmanned, rotary, and fixed-wing aircraft that they support. That opportunity led me to collect several innovative improvements, in other words, desirements, they expressed interest in obtaining. Today, I'd like to present some of those desirements that I've collected over time and combine that with the procurement requirement trends that present both opportunities and challenges in the future. One of the most important advances in military technology since Desert Storm in 1991 is the increasing use of precision-guided munitions, aka smart weapons. Smart weapons are able to achieve repeatable delivery accuracy based on improved communication with the aircraft that carry them, and often off-board data used to refine guidance to the target. Today, they are the weapon of choice for militaries worldwide. That demand is enabling arms producers to deliver record numbers of smart weapons. As I'm sure we are all aware, smart weapons rely on more complicated interfaces with the armament and the aircraft that carry them. Traditional passive, stray voltage, and continuity test sets alone cannot functionally test those test interfaces. However, most militaries today still have their maintainers using that same type of test equipment that was delivered with the aircraft in the late 70s and early 80s, when there were very few smart weapons available. Therefore, in many cases, they are unable to perform the functional checks on their armament that would ensure a high degree of reliability on the flight line. That is generally not true for avionics and radar systems, since they often rely on a robust built-in test capability. To give you an example of the growth of smart weapons use, let's look at some of the figures from the last 30 years. During Desert Storm in 1991, only about 8.5% of the munitions employed were smart. Moving forward to Operation Iraqi Freedom in 2003, that figure rose to 68%. And in Operation Inherent Resolve, the campaign against ISIS in 2017, precision-guided munitions represented over 95% of the weapons employed. In fact, today, most aircraft deployed in various AORs are loaded with 100% smart munitions. And for those weapon systems to be truly reliable, to make sure that the weapons will always function when commanded to, and never ever when not commanded to, test sets need to be up to the challenge. Common across aircraft, reliable, deployable, easy to use, and provide comprehensive test capabilities to ensure an aircraft's armament systems are fully mission capable. As these precision-guided weapons are integrated onto an ever-increasing number of legacy and fifth-generation aircraft, maintainers are seeking innovative test solutions to better allow them to ensure their aircraft are FMC when aircraft arrive. To be specific, many maintainers have expressed concerns about the reliability and deployability of their existing test equipment. Logistical challenges such as fielding and maintaining test sets in environments can range anywhere from scorching deserts to frozen plains. Supporting and using multiple different test sets, each for a different purpose or supporting a different aircraft. Test equipment often requires large, cumbersome paper or digital checklist or both. To continue using the legacy support equipment that was originally deployed for an older generation of aircraft, munitions, or avionics to support the new capabilities that are being added to older aircraft, as well as the new aircraft that are coming online today. This often requires test sets that fall short of checking full functionality of the armament before loading smart weapons. Large deployment footprints of equipment, both for shipment and use on the flight line. In other words, multiple large two-person carry boxes to perform a specific test. They are desiring test sets in the size of your cell phone, capable of connecting to the aircraft possibly via encrypted Wi-Fi or Bluetooth, and capable of emulating a weapon or test armament functionality. Excessively long test times to conduct go, no-go tests and follow-on troubleshooting, many of which do not comply with manning standards, resulting in exceeding doc statements generation timelines. Lack of test set and test data commonality, preventing trend analysis, predictive maintenance, supply forecasting, and mission modeling. And of course, the ever-present and real-world threat driving the need for cybersecurity and encryption. Given the funding challenges that normally accompany either new procurement or major modifications, test and training are often the last to be funded, causing maintainers to have to make do once again with existing test sets. A situation that's gone on way too long in many of their minds. To summarize, what maintainers have expressed to me over time is the desire for smaller test sets, in some cases requesting systems as small as your cell phone and with fewer or no cables to enable easy deployment and reduce clutter on the flight line. Rugged, airman-proof test sets with high mean time between failure and long calibration cycles. Commonality of test sets to support multiple aircraft deployed environments and enable condition-based maintenance scenarios. Innovative test capability that provides comprehensive testing of systems and can easily add future test capabilities as new munitions are fielded. Faster test times with test data that can be captured and eventually utilize artificial intelligence to enable preventive and predictive maintenance environments. Recognition that there are new technologies available today to allow maintainers to increase the chance of first-time mission success, and funding needed to match these capabilities with the total weapon system capabilities that exist today. ATE with reduced size, paper or digital checklists to work with on the flight line. Many of the ones today are so cumbersome. ATE for cyber protocols for even the most sensitive aircraft. And ultimately, 21st century test equipment needed for the 21st century armament maintainer to execute any mission set today and tomorrow. We have the chance this week to have a lively dialogue between warfighters and industry to further flesh out these ideas. I hope that you will take advantage of the time during LOA to do just that. We'll be dispersed with only a minimum number of maintainers, often multi-skilling the maintainers, to have to do more than one job. Our units will have to operate more independently with what they have on hand. General Holmes, the former ACC commander, stated on 19 June 2019 at the Air Force Life Cycle Industry Days conference. General Holmes went on to say that industry and government should work to boost reliability and reduce the movement of spare parts by exploiting modern sustainment initiatives involving predictive maintenance algorithms. General C.Q. Brown sums it up best when he says, accelerate, change, or lose. Therefore, we must always look for every opportunity to leverage technologies that can enhance the capabilities of the systems that warfighters depend on. Test sets today need to be common across multiple aircraft and quickly upgradable at the speed of relevance, allowing the emerging technology integration without major rework. Technology like RF identification, wireless communication, use of artificial intelligence, and updates to cybersecurity are some examples which will ensure maintainers are using the best available test equipment. We will need to take a look at how 5G technology can be leveraged for more than just the telecommunication applications that we are hearing more and more about. With 5G's low latency and high data rates, real-time data transmission and sensing, as well as test set tethering, can be an enabler of even more precise weapons in the future and better predictive maintenance. We have already seen unmanned wingmen being flown by Kratos and Boeing, as well as swarm technology by AFWERX and AFRL. An F-35, for example, is envisioned to be able to lead a group of unmanned aircraft, much like a quarterback leading a team, coordinating and directing the attack and employing weapons while remaining at a distance. Armament maintainers will be challenged when testing this mixed configuration on the ground of aircraft, manned and unmanned, to ensure the complex and dynamic interfaces of the systems are fully capable with reliable communication and ready for successful weapons employment. As the development of Agile Combat Employment, ACE, continues, which could require more frequent and smaller deployments with fewer personnel and fewer aircraft, how do we make sure that the available test resources, especially at the O&I level, provide the required capabilities at the speed and fidelity required for maintenance and sustainment far away from home station? The answer to both is probably more multi-aircraft supporting test equipment that is easy to deploy and operate, much like what is happening in the bomber world today with the Bomber Armament Test Program, consolidating B-52, B-1, and B-2 armament test. With 5G early in its implementation, some are already working to plan what 6G will look like. And as you know, although there is movement afoot to have more military data accessible through the cloud, much work in policy and security arenas remains to be done, but it will probably happen. Since 1998, DISA has played a critical role in enhancing the security posture of DoD security systems by providing STIGs. The STIGs contain technical guidance to lock down information systems and software that might otherwise be vulnerable to malicious computer attack. The STIG identifies nearly 300 risks, categorized by severity, that apply to all DoD developed and administered applications and systems connected to DoD networks. While not all these requirements are applicable to automated test systems, there are some key requirements that certainly apply, including TPS event log recording, user audit log recording, idle time locking, user account handling, password policies, and configuration audit changes. Leading suppliers of test software have already identified the key STIGs that apply to this space and are working to implement these requirements to ensure maximum compliance and protection against malicious attacks. The DoD and industry are actively working to understand the constantly evolving cyber threats that our digital systems are facing. Recently, a team of white hat hackers was invited to try to exploit vulnerabilities in the F-15 flight system, and they succeeded. The good news is that they revealed issues that can be addressed before they are discovered by the adversaries. The Defense Digital Service recognizes severity and is in a continuous process that requires regular evaluation, so that you can expect to hear more of these kind of stories in the future. And the more we hear in peacetime, the more we'll be protected in wartime. In fact, if you have a current contract to deliver test equipment to the DoD, I'm certain you will have a set of robust cybersecurity requirements to meet. But even with some of these emerging technologies in early stages, we need to think big. Figure out how to take the best of what's out there and make it even better, and more importantly, make it work for the warfighter. There are hypersonics, directed energy, robotics, satellite constellations, and a host of technologies coming out of the innovation hubs like AFWorks and SoftWorks that many of us may not even be fully aware of yet. Maybe some of you are involved in these breakthrough technologies and are on the ground floor of figuring out how best to develop strategies where they will be needed and enabled. Marvin Test Solutions is a proud member of the Marvin Group. Marvin Engineering Company is our parent, and it's been around since 1963. Marvin Land System is co-located with Marvin Engineering in Inglewood, California. Marvin Test Solutions, a company founded in 1988 and brought into the group in 1997, is located near John Wayne Airport in Irvine, California. Marvin Test Solutions is a vertically integrated aerospace test and measurement company that takes our customers' requirements seriously and provides long-term unrivaled support to the test equipment we field to ensure that our customers have reliable test equipment throughout the life cycle of the aircraft that they're supporting. We are globally deployed in over 34 countries today. I'm going to shift specifically to the MTS 3060 Alpha Smart Can. We're now on our second generation of the Smart Can, which is deployed in over 12 countries today. The Smart Can is the only handheld armament test set on the flight line today that provides full functionality testing to the 1760 bus, including communication, arming, and release prior to the tons of munitions being loaded on the aircraft. It's versatile enough to provide troubleshooting even between integrated combat turns when the time is very short for the aircraft on the ground, because the test time, as you'll see later, is extremely quick while the test is very thorough that the Smart Can performs. Time that cannot be provided by any other flight line test equipment today testing armament for the U.S. Air Force aircraft. It's handheld, repairable, and powered by 6 AA batteries, which allows rechargeable batteries to be used. It's undergoing certification at the moment by Lockheed Martin Aeronautics in their F-16 System Integration Lab. And it was offered by a company called Compellum, along with their AI solution for predictive maintenance, to the U.S. Air Force and Air National Guard. It was in fact awarded a Phase 2 approval but lacked the funding. So Compellum went back for a direct phase 2, and their customer is eagerly awaiting the award so that they can now proceed with demonstrating how AI will take the data provided by the SmartCan and actually provide predictive maintenance for armament. The technology with the SmartCan is not limited to current smart weapons. It covers all smart weapons, but it also is set for the future with multiple interfaces, including 5th generation interfaces that are being used today. And when we made it the 3060 Alpha, we involved a much larger connector with more pins than are needed for any smart weapons today, leaving growth for the future. It generates audio and video signals that help in that troubleshooting I mentioned earlier for weapons like the AGM-65 and AIM-9 missiles. And it gathers very sophisticated parametric data. And in fact, on Gen 2, for your higher level maintainers, we actually show what the variance is of the different tests. So a 5 or 7 level may actually know what the problem is, or getting close to a problem before the actual parameters are exceeded, hence providing a little bit of trend analysis even to the naked eye prior to taking all the data that I'll show you later and performing trend analysis either manually or through AI. This is what the SmartCan comes packaged as. It's a Pelican case. It weighs no more than 47 pounds for the most highly equipped F-16 configuration. All the cables, the adapters, the self-test, are all included inside this enclosure, which has wheels and a handle, and any airman can pick it up and carry it. It's only 47 pounds, or they can wheel it up and down the flight line as needed. It self-tests itself every time that it's turned on, and it checks its calibration. In fact, we've had such high reliability figures over the years that we have fielded this since 2011 that we are now recommending a 4-year calibration cycle. And that calibration can be checked on the flight line with just a digital multimeter, which I'm told all squadrons have. These are the aircraft that the SmartCan is deployed on today. If the print is in white, it's already deployed. If it's in amber, it's available for use on that aircraft. And if it's green, it's been demonstrated before. As you can see, most of the aircraft here have already successfully had the SmartCan deployed on them, and it's supporting them since 2011 in many cases. The timing of the SmartCan and the reduction of test time was found to be very important in some of the demonstrations that we did over the past couple of years. For instance, on a LAU 129 testing both AIM-9 and AIM-120 using current USAF test set equipment and checklist, it takes 39 minutes for an experienced crew per launcher to do the test for both missiles. However, in the demonstration using inexperienced aircrew crew members that were just picked off the flight line, so inexperienced maintainers, just picked off the flight line who'd watched our engineers during the morning do some testing and integration, they were able to start with a closed Pelican case on one wing and move and test all 4 launchers for both missiles and close the Pelican case on the other wing in just 37 total minutes, compared to 39 minutes per launcher. When you take that amount of time savings for just 24 aircraft over a year and checking, only running these numbers against certain tests, that saves over 1,400 hours annually. And as the Air Force is trying to reduce the amount of time maintainers have to spend on things they shouldn't have to spend as much time for, that's why I believe it's important to accelerate the use of innovative equipment and to change how procedures are done across all the aircraft to capture those types of savings. In the cyber and nuclear ready area, the SmartCan today is the best cyber security protected handheld test set for armament on the flight line today. There is none like it. And in fact, we added a removable hard drive in the form of an SD card so that if it was used on classified aircraft or weapons, you don't have to lock up the entire SmartCan. You just lock up your SD card. We designed the SmartCan around the Air Force manual and Air Force instruction numbers that you see on the slide so that it would be easy to go through nuclear certification in the future when certain aircraft are going to call for it, as F-35s, for instance, pick up the NATO missions F-16s are doing today. It's the only robust handheld test set out there today that has the capability to perform the nuclear mission. And finally, here's what the test data looks like. It's parametric test data. Every run, every maintenance run is saved, and there's plenty of storage to save dozens worth of sorties. But in a perfect world with an AI solution, you would download the data after every sortie, upload it encrypted to the cloud, run it through the algorithms of an AI company, and get back to predictive maintenance trends and or alerts for the supply system to be used so that you can actually keep these aircraft flying longer with less unknowns in the system. Predictive maintenance is so much better than preventive maintenance in terms of cost and time. In closing, I'd like to once again thank the LOA committee for giving me the opportunity to share some thoughts regarding the future of tests in the military with you here today. Thank you all for being here. Thank you for your questions that you've been sending in. I look forward to addressing them and to continuing the conversation even after this week is over. Have a great week at LOA. Thank you.
Okay, welcome to the questions and answers section of this program. Joining Steve for this portion will be our Marvin Test Solutions Warfighter Support Solutions Manager, Adam Wells. Adam is a retired senior master sergeant from the United States Air Force. So let's begin. The first question comes from AFMC and USAFE. Is a SmartCan a common solution for the fourth generation aircraft only?
That's a great question. And for those of you that haven't had the chance to meet Adam in the past, Adam has experience on the F-22, F-15, and F-16, and considerable deployed downrange experience as well. And he's been on our team now for the past 2 years. So in regards to the systems that the SmartCan can work, it's currently deployed on a lot of fourth generation aircraft, but we designed it to work across all rotary, fixed, manned, and unmanned fourth and fifth generation aircraft. And it actually goes beyond that. Any ground system or naval system that uses armament can find a home for the SmartCan to reduce the amount of time and effort it takes to ensure that their weapon systems are fully mission capable. Adam, anything to add?
You said it very well, Steve. We took the initiative to plan in, like you said, for fifth gen. We even put the communication channels for the F-35, which is a CAN bus, to make sure that we are relevant today and relevant tomorrow.
Great.
Okay, thank you both. Second question comes from AFMC, USAFE, and PICAP. What is the time savings for maintenance personnel using the SmartCan?
Well, the time savings is one of the biggest attributes of the SmartCan. In actual field trials at Air Force and Air National Guard bases over the last few years, using inexperienced crews with the SmartCan. They were experienced armament maintainers from different levels, but they had never been formally trained on the SmartCan. In the case of an F-16 with a LAU-129, checking both the AMRAAM and the AIM-9X missile, it typically takes an experienced crew 39 minutes per launcher with the currently fielded O-level test sets supporting F-16s across the Air Force. When the inexperienced crew was given the SmartCan and required to test all 4 launchers on an F-16 for both missiles, it took only 37 minutes from beginning to end with an inexperienced crew, meaning they had only seen our engineers that morning do integration on that particular airplane, and it only took 37 minutes. So Adam's done some of the math over time for just a 24 UE squadron. Adam, what was the savings that you came up with just the 60-day check without changing any of the current procedures that the SmartCan might allow for troubleshooting in between integrated combat turns and other sorties? What did you come up with just the 60-day check savings?
As you said, Steve, we realized a significant time savings during the demonstrations. When we calculated for the savings during the scheduled maintenance, those are on 1,400 man hours saved just for the scheduled maintenance checks. You can guesstimate how many how many man hours you're going to save throughout the course of a year at a single unit when you factor in all your PRD checks, all your failed checks, your unscheduled maintenance checks. And then since that demo we took, what the warfighters actually were telling us, and we made some modifications to the tester and our cabling to combine capability, multiple capabilities into the single cables. And this time savings has actually shown to be much greater than the original demonstrations.
Thanks very much. Jessica, any other questions from the audience?
Yes, next question comes from the Air Force Material Command. How long will the SmartCan maintain its power source and storage?
Well, we've got a very unique and easy to obtain power source. It's called the AA battery, widely fielded throughout the world, and it doesn't require any special AA batteries. Of course, we recommend a certain type, but you can buy any AA battery. It holds 6, which allows enough charge that you can use rechargeable batteries. 6 rechargeable batteries. And those batteries aren't installed until you actually need to use it. When I go to the store today to buy AA batteries, they usually come with a 10-year warranty for storage. The SmartCan itself has an internal clock battery, just like all computers do. Ours has a 10-year shelf life. So when you if you were to store the SmartCan for contingencies in your WRM storage facility, you could count on that SmartCan being packed up for 10 years and not having to do anything with it. If it's going to go longer than 10 years, you'd want to check that internal battery. And if I were you, I wouldn't have AA batteries sitting in the case because of corrosion that all batteries have over time. So they'd be stored separately. So I think you're going to find that that particular test set is extremely flexible, agile, and deployable. And Adam, can you talk to the temperature range for storage as well, and maybe use?
Absolutely. This and many of these topics are some that I've wrote about in our blog series, because power supply and operating conditions is a huge issue across testers in the DoD. Our operating range is within specs, and within line of most testers you'll see, it's from -20C up to positive 57C for storage. Operating is, or I'm sorry, that's for operating. Storage is from -51C to positive 71C. And this can be supplemented easily in the extreme environments that the DoD is testing to by simply using hangars, heating units, different supplement when you get down into that cold range. The other benefit of our tester in these ranges is the typical work rest cycle, which is about 15 minutes in the environment and 45 minutes of rest. Well, our test times are so fast, as we previously said, that you can accomplish your tests within that operating time in those environments of your 15 minutes and get into your rest cycle much faster as opposed to some of the legacy testers, which will take you 30, 45, even an hour just to set up sometimes. That pushes you outside of your operating window of 15 minutes. So a lot of these tests cannot even be accomplished, even be thought to be accomplished in the extreme environments because of those conditions.
Right. And especially when you consider the currently deployed testers can take up to 45 minutes to an hour just to have multiple people carry them to the site and set up to get ready to do the test. And then as we've seen, it's anywhere from 45 minutes to an hour and 10 minutes to conduct a test. And then you have tear down. So when you add that work rest cycle that you just described, you can be out there for hours just to conduct one test. When the SmartCan takes minutes to set up, minutes to run the test, and minutes to tear down.
Excellent. Thank you, Adam and Steve. Next question comes from PECAF and ANG. What advances are utilized to ensure you can not only keep up with what's happening now, but the future?
Well, again, that's a really good question from the field, because over the years, we have paid close attention to what our customers have asked for. And the first generation of the SmartCan, which we fielded in 2011, had capability to expand. But as we looked at it, we also looked at the munitions that were coming on board and the future state of armament. And we said, we need to go beyond what's being asked for so far. So we created Generation 2 based on a lot of the comments that I read back to everybody during my presentation earlier. And so a lot of the weapons that the SmartCan can test today are widely deployed across the world. But there are weapons that are being deployed today that will be used for the first time in combat. We've added connectors on the SmartCan with more pins than are required for any of the weapons today. We've added interfaces for the aircraft and armament that we have not had a customer asked to use yet. As Adam mentioned earlier today, CAN bus for the F-35, which is the main interface for that, and for small diameter bomb, the MMSI connector, that's already built into the SmartCan. And there's a huge amount of memory that's available. So everything that the SmartCan can test today can be added to in the future. And we actually sell a kit and training to the customer that they can actually add their own weapons, create their own TPSs in the future to add weapons that they may not want to let us know that they have, or they may be in the heat of battle and need to add that weapon quickly because it's now being deployed when it was never deployed in peacetime. And that is a real world contingency that has affected the U.S. Air Force. If you go back all the way to Desert Storm, there were weapons that were delivered to the field that had never been used in peacetime. In fact, they were developed during wartime. And so we've built that in. And the one thing about being an aerospace test and measurement company, our pledge to the customer is we will not let your test equipment go obsolete while you're using it for the aircraft that you bought it or the ground system that you bought it for to test that armament. We're going to stay with you and continue to make sure that it works properly. And the capacity is built in so we can grow, the SmartCan can grow as your service grows. Because let's look at the F-16 for a second. When it was first fielded in the late 70s, it had only AIM-9 Papas and Mark 82s and Mark 84s primarily for the weapons. Today, those are the least likely weapons that would ever be carried on a U.S. Air Force F-16. Almost all smart weapons are being carried today. And so we built the SmartCan to look at the F-35 in a very similar way. The F-35 is starting with smart weapons, obviously, today, but it'll have even smarter weapons 5 to 10 years from now. Adam, anything else to add to the capacity that we've built in?
You hit it quite well, Steve. This is actually one of my primary roles of our team here at MTS is to go out to the customers to understand what the needs are and to come back to our engineering team and try to meet those goals. So the engineering team has gone to great lengths to leave capacity in the test set for future expansion, knowing that in the future, there's going to be wireless needs. In the future, there's going to be different needs that we don't know about quite yet. And in some cases, sometimes the customers won't let us know. So we have to leave that expansion capability there. So even if a customer comes in and says, "Hey, I got this widget I need integrated, I can't tell you about," we've left it there, and the engineering team has, like I said, gone to great lengths to make sure that it's there. All the known communication channels are there, even if we don't have a customer or a ConOps that needs it now. It's easier to put it in now, lay it in now into the design rather than going back and engineering it later. We've worked with AI companies to prove that we can actually approve and provide realistic predictive maintenance and trend analysis results to the maintainers. We've gone as far to prove that we can actually send this information wirelessly. It goes on and on. And it's a fun and exciting test set to work with.
We've actually proved out that expansion capability with some existing customers as well. When we first fielded SmartCAN, for some customers, they were using AIM-9 mics, and they've since graduated to AIM-9X. And we didn't have to swap out the SmartCAN. We just wrote a different TPS for them. And that's something that Marvin Test Solutions can do for the customer going forward as well. We can stay as engaged or disengaged as the customer wants after delivery of the SmartCAN.
Next question comes from ACC and AFMC. What is the field repairability of the SmartCAN, since test set turn times is one of the major issues in the AOR?
So this is an interesting one.
Okay.
We designed and developed the SmartCAN to be airman proof. Now, don't take that as a challenge, okay, to prove us wrong. But we built in a rugged system and really thought through all the different ways that airman who's out deployed somewhere using the SmartCAN could, quite frankly, damage or destroy it. Unintentionally, of course, but in the course of working late night, middle of sandstorms, rainstorms, whatever it might be, things happen. So we've anticipated a lot of those problems in advance. So we've made the SmartCAN case itself airman proof, meaning you can drop it from a certain height, about 6 feet, and it'll bounce because it's got rubber edges. It's not going to roll off the wing, even though it's very easy to hold and weighs less than 4 pounds, because we've squared the edges. We have treated the buttons so that they don't wear out. We've made the screen such that it is quite readable during daylight, bright daylight hours. And we built in things to the cables like Kevlar cord, just in case someone decides to hang from the cable when it's plugged into a pylon or a launcher. Of course, that rarely happens in front of supervisors, but it does happen. So we built that Kevlar in to help keep those cables together. And then one of the ends, and I'll let Adam get into the detail of this, but one of the ends of the cable can actually be field repairable. The end where pins would most likely be damaged. The other is not, because the other end rarely gets damaged. Given the way that the SmartCAN is put together, over the past now almost 10 years, what we see coming back to us are cables, a request for a cable, because somebody drives a bread van, over the cable and crushes it. So they ask for a new cable, or they send it back to be repaired. And if it's a certain end, it can be. If it's not, then it gets replaced. We've had very few SmartCANs come back to us to be repaired. If the SmartCAN itself fails, they send it back to us. Within 30 days, we've got it back to the customer. And that's typically why a unit will buy a spare. Going back to our storage answer earlier, you can store that spare, not worry about it. When you need it, pull it out and use it over a 10-year period before you even think about changing the internal battery. But the other piece is that because it is so airman proof, we're almost like the Maytag repairmen back here from that commercial. We don't get a lot of calls, but when we do, we're quick to respond and turn that system around. Adam, what are some of the other things that you've seen that made sense from the field?
So as Steve said, and I'll show you, try to get a visual here, and we've developed the Smart Can to be as airman proof as we can with rubber edging, rubber button covers, ports that are closed so they don't get into the environment and the elements. Everything that's will break and wear out, like your button covers, is easily taken off and repairable. The cabling, the parts that are going to wear out, which need to wear out, like your striker point leads. You don't want our tester wearing out your striker points. It's harder to fix the rail. So we made those so that it's softer metal. It can actually wear out, but those easily are screwed out, in and out and replaced. As he said, the cables on the terminal end are repairable. We find that bending pins is the most common cause of damage, outside of running them over or just straight destroying them. So that end is easily repairable with tools that you have in your Daniels kits. The receptacle end does not damage near as quick as the terminal end. So we've made that end highly robust so it can actually withstand a lot more abuse. However, the drawback is it's not field repairable, but if a customer does desire to have that repairable, we could make it repairable at the field level. It would just come at a little bit of a less robust cable end. And then internally, there's even customers that go as far as want to have their PMALs or their labs be able to swap cards like basic, like any main tester, big box tester. And we do provide the training and capability if the customer wants to repair down to that level. Outside of that, really, we don't find a lot of need to repair beyond that level in the AOR. The other major part that keeps our tester in the AOR is our cal cycle. Our cal cycle is one of the main limfax of most testers. It's a short cal cycle, has to go back for a long process. Our tester calibrates every time you turn it on. So we put a chip in there, it's got measurements. And when you do our calibration, our PMAL calibration, all you're doing is making sure that the measurements have been drifted. It takes 5 minutes. It takes a DMM, a digital multimeter in the case. It could actually be field or user calibrated. And it's on a 4-year cycle. That's what we've proven. We have data to support up to a 4-year cycle, and we're collecting data to hopefully push it out to even a 5-year cycle, maybe someday in the future. The point is we developed this to stay in the AOR, to not need to leave the AOR.
So it's pretty flexible in that for some customers, over the past 2 years now, we've actually developed a kit, a spares kit. To Adam's point, they wanted to be able to change the cards. They didn't want to wait even 5 days to turn around. They wanted to have cards that we would train their technicians how to take the Smart Can case apart, troubleshoot, find the right card, and have a supply of those cards on hand to repair at the point of use. Now, obviously, the closer to the war fight the customer is, then they may want to have that, and we develop that at a customer request. So those are the type of things, and for a customer that wants to be able to take and move repair from Marvin Test Solutions to a depot, we've made that more than available across many of our test solutions. If for instance, the Air Force wanted to pick up certain test equipment that we have and be the maintainer of it for life, we would train them and keep the supply chain going so that they could do that work. Very flexible in that regard. But the good news is, going back to the mean time between failure, which is allowed for a 4-year calibration check cycle that Adam talked to, and the fact that it's kind of lonely back here when it comes to Smart Can repair. They're pretty much airman proof. And I look forward to hearing stories in the future of airmen who say, well, I proved that it wasn't in this one or two cases, and then we'll figure out how to move ahead. Back to you, Jessica.
Thank you. Last question comes from PACAF. Do we use universal cables as extender cables, thus lengthening the overall cable and making it heavier?
Well, in addition to those universal cables making it heavier and bulkier, requiring some of those multi-purpose person teams to carry out multiple boxes, multiple large boxes to conduct a single test, it makes it extremely costly. Because the longer the cables are, the more copper, etc., very expensive and very heavy. So that kind of goes against what we do. We try to make tests easy to deploy, easy to maintain, sustain, train to, and use. And so the last thing we would ever do is create a universal cable. Those universal cables they're so long, they usually have extra power supplies. They increase the resistance in the wires, which could sometimes lead to false positive or false negative type testing. And so we actually have customized cables to the work that's being done, for the work that's being done. But in the case of the most heavily armed aircraft that we supply today, all the cables fit inside that Pelican case that I showed in the briefing toward the end of my presentation. Weighing about 47 pounds, any airman can pick up 47 pounds, but we make it easy there too because we put wheels and a handle. So as they're going from aircraft to aircraft on the flight line, they don't have to carry it, they can roll it. But all the adapters, all the self-test, all the cables, they all fit inside. Now, Adam was a big driver on that because others have asked from time to time, can we put these big monster universal cables? Adam, you want to tell them what you told us about those?
As we've discussed many times, anytime you add length, you add cost of the kit that the taxpayer has to fund. As you greatly pointed out, it's another item that's going to fail. It's weight that I got to carry around. It's resistance, as we talked about, and as those cables degrade or as maintainers don't maintain them to the highest standards, cleaning pins is a great example. Dirty pins increase your resistance. It's going to drive your test values to different ends, either the maxes or mins, and you're going to end up chasing false positives and negatives and changing parts early. Cabling needs to be as close to the item that you're testing as possible. The smaller the cable, the more higher fidelity and tests you're going to get. And honestly, the cheaper the cable is going to cost and less you got to maintain.
Well, especially when there's a couple folks in the audience today who are just dying to get a hold of one of these so they can go out and see how airman proof it is. And if we had one of those 30-foot long universal cables with a power supply or two in it, they'd run the breadband over it, and they're going to run over the end that can't be repaired. And then think of the cost when you have to order a new one of those cables. It'll be quite large compared to the cables that we have been deploying. And so we don't use the universal cable, but we also have the capability to do the type of cabling that the customer may want. So spider cables, multiple bomb rack tests for like the CFT on the F-15E. We've demonstrated we can put that together in pretty short order. And just if you wouldn't mind, Adam, you can talk details on that CFT test that we did. On the exact test, there was one or two things we didn't do because it wasn't required, but we did this on our own initiative. And what kind of time savings did we show to that wing?
So we got asked if we could, during one of our demos on the F-15E model, if we could also do the CFT. The E model has a requirement to check all 6 stations, mainly looking for crossover voltage. So when you get firing voltage on station 1, you don't get it on station 3 or 6 or whatever. So like Steve said, that was short order. And in the course of about 4 days, me and the engineers were able to put together a mock demo cable. Again, it's one of our larger cables because it has to stretch the span of the entire CFT. We designed it a little differently than the current cable. So we saved a lot of space, a lot of weight. And for the purpose of the demo, we didn't go through all the rack hooks, resetting and sensing switches and all the additive checks of the bomb rack. We just mainly proved out the voltages and the crossover voltages, and we were able to do it in less than 2 minutes. This Test has to normally be conducted by the 198 test set. It takes a very long time. Previously working on the E-model, it can take a crew to do all the checks up to 4 or 6 hours. Of course, that's doing everything. We were just proving out one portion of it, but it's still, for that portion, we saved about 45 minutes. We definitely saved about an hour in setup and tear down oil. And one of the things when you have short cables, you do have a risk of dangling the tester and adding damage that way, people might be thinking. So we've engineered a very difficult or a very complex solution in a strap, a simple strap that wraps around the tester. You can hook it to anywheres, and you now can keep the test set up near the piece that you're working on. Relieves the stress on the cables, plus you could go hands-free and just sit there and monitor your tester.
Well, thanks very much. That was a pretty happy day at that wing when the armament maintainers from chiefs down to the staffs got a chance to see that. I remember a lot of big smiles on their faces, and they kind of wanted to tackle us as we were leaving. They didn't want us to take the smart can away that day. They kind of wanted to use it right away. So, Jessica, any other questions from the field at this point?
No, that's it. Adam, Steve, thank you both so much for your time. This concludes the LOA segment, Marvin Test Solutions, making test easy for the 21st century armament maintainer. So thank you so much for joining us here today. If you have any further questions, please don't hesitate to reach us via the following contact information that will be shown on the screen shortly.
Thanks very much, Adam. Thank you, Jessica, for moderating. And thank you all for attending today. Please feel free to contact any of us that you see on here. If you're looking for a meeting, can't go wrong with contacting Jessica. She can get anybody on this screen today set up with a meeting for you for any follow-on questions to address today. And Jessica, if you want to share your screen now, and we'll conclude the session once the screen is up. Well, thank you all again for attending, and we look forward to follow-on questions and perhaps a meeting or two after this session. Thank you all again.